Hello, good morning. Before we begin, please make sure that you've checked in for attendance by completing the Google form that I've placed in our Google Classroom. Here's today's learning target. You're going to be able to find the volumes of spheres and understand the relationship of the volume of a sphere to the volume of a cylinder. Now, last classes we've been covering finding the volume of a cylinder and finding the volume of a cone. And you know now that the volume of a cylinder, or any geometrical solid, is the area of the base, whatever the shape of the base is, finding that area times the height of the solid. So since for a cylinder the base is the shape of a circle, it's pi r squared is the area of a circle times the height for a cylinder. That's the volume for area of a cylinder. And last class we covered volume of a cone. Now, it is not the entire volume of a cylinder, even though it may have the same radius of the circle and it may have the same height, but it's only a fraction. You could actually fit 3 cones inside this cylinder for the volume. So we have to multiply the formula for volume of the cylinder by 1/3, or divide the volume by 1/3 in order to get the volume of a cone. And this is the problems that we were working on last class. The volume of a cone is 1/3 pi r squared. So the pi r squared is still the area of the base times the height, and the difference between the cylinder and the cone is that we're incorporating this coefficient of 1/3 right in the front. Now, very quickly, I want to do a couple of warm-up problems. So take a look at these problems, and I'm going to pause. I want you to pause your video, because I want you to complete both of these problems. One's find the volume of a cylinder, and one is the volume of a cone. These should be quick review for you. Remember, please use 3.14 for your value for pi, and make sure you pay attention to your units. So go ahead and pause the video and find the answers to these 2 questions right now, please. You should have found both answers. Let's take a look at the first one. Number 1, find the volume of the cylinder that has, and this has a diameter of 14, but what do we need? We need the radius. So hopefully you paid attention to that. We know that the volume of the cylinder, we just repeated, is pi r squared times the height. We don't need the diameter of 14 inches. We need the radius. We need to divide the diameter by 2 to get 7 inches, and we plug that in and we square it, and the 7 inches squared is going to be 49 inches. We're using 3.14 for pi times the 20 inches of the height, and when you multiply this all out, we're going to round all our answers as we've been doing lately. For all our volume answers, we're going to round to the nearest tenth. So this answer should have been 3,077.2 inches cubed. Remember, pay attention to your units, that they're cubed. And hopefully you arrived at that answer. The volume of the cone. So here's, we're going to use the 1/3 times the pi r squared, and then times the height. Our radius is 3 feet. Our height is 8 feet. So we're going to do 1/3 times pi, 3.14. We're going to square the 3 feet radius to get 9 feet squared. And remember, once you, even though you have 1 tick mark for height, if you've used the 1 tick mark for feet, when you square it, you need to revert it to feet. Actually write out feet, or use this abbreviation for feet. So we have 3.14 times 9 feet squared times 8 feet for the height, and then instead of multiplying by 1/3, I'm just going to make sure I divide by 3. That's the same thing. Multiplying by 1/3 is the same as dividing by 3, and we covered that last class. And when you do the 9 feet times 9 feet squared times the 8 feet, you get 72 feet cubed. And then we multiply by 3.14, actually, and then I divided the 72 by 3. So it doesn't matter what step you divide by 3, but it has to get done at some point. I just thought it was easier to make 72 feet cubed divided by 3, 24 feet cubed, times 3.14. The decimal value is 75.36, but we're rounding to the nearest tenth in all of our answers, so it's approximately 75.4 feet cubed. Hopefully you got those 2 answers for our volume of a cylinder and volume of a cone. Now, I have a question for you. When we find the volume of a figure, the units always have what exponent? Since we've been doing volume lately, the last few lessons, the units always are what? If you've been paying attention, the units are always, the exponent is always 3. So the units are always cubed. That's what we're emphasizing, that the units are cubed, because we're trying to actually fill a 3-dimensional space. Now, we're representing a 3-dimensional figure on a 2-dimensional flat piece of paper. But if I were to fill this up, and this answer was 3,077.2 cubic inches, I could actually fit 3,000 little cubic inches that had depth, height, and width. They're 3 dimensions, so they have to be cubed. So all of our volume answers are cubed answers. In the volume formulas that we've been doing, where do the units come from? How do we get cubic units out of the formulas that we've been using? So let's take a look at the volume of a cylinder. We have pi. Does pi have any units? No, pi is just a constant. It's 3.14. It's the irrational number that goes on forever. That is the ratio of the circumference of a circle to its diameter. The radius is going to actually be a unit. It's going to be a measurement, whether it's inches or centimeters or feet or yards. That is a unit of linear measurement. We square it, so that makes the unit squared, and then the height is also a linear measurement. So that's where the cube comes from. It comes from the radius units being squared times the height units, which is going to give us cubic units, no matter what units they are. They're going to always end up being cubic units. So it's important to understand that whether we're talking a cylinder or a cone, we're going to have linear units squared times another set of linear units, which is going to give us linear units. Well, not going to be linear anymore. They're going to be cubic units. So that's where we get all volumes of any geometric figure are going to be cubic. Now, today's new lesson, volume of a sphere. Now, a sphere, let's take a look at this. I only have one thing I can measure, and that's the radius. I could measure the diameter, but that's just the radius doubled. So I don't really have a height like we did for the cone and the cylinder. I just have, the height is just going to be the radius times 2, which would be the diameter of the sphere. And again, we're trying to represent a 3-dimensional object on a 2-dimensional flat piece of paper. So instead of, if I didn't draw this dashed line and this other circle sticking out, it would just look like I'm drawing a circle. So I'm trying to show you that we have depth going back just like we have for cones and cylinders. And I'm putting the radius here from the center of the sphere out to the edge. That's the perimeter. So that's actually what defines a sphere. It's the center of all the points that are equidistant from the center of the sphere. So no matter which way I draw the radius, it's going to be the same, just like as if it was a circle, except this is 3 dimensions. So we just talked about that volumes always have to be in cubic units, but I only have one linear measurement in a sphere. So how am I going to get cubic units in my answer? Because I don't really have a height, because the radius is just the same. So I want you to understand that, because in the ones we just did, and we covered in the last class, the cylinder was radius squared, and the cone was also radius squared, because they were related. But now, I need cubic units, and I only have one linear measurement. Well, because of that, we're going to actually cube the radius. That's going to give us our cubic units. It's the only measurement that's going to be linear. We need to get cubic units for our volume, so we're going to cube the radius. And the fraction this time is going to be 4/3 instead of a third we had for a cone. So it's pi, because it's still circles involved, and we need that relationship of pi to the circumference of a circle. But we're going to cube the radius, and then we're going to multiply it by the fraction 4/3. Now, I'm not going to go into, in this lesson or even this course, why it's 4/3. That's actually beyond the scope of the parameters for this geometry course. When you get to calculus, whether you get to a senior year or when you're a freshman in college, you're going to learn how to derive this volume formula of a sphere and see why it's actually 4/3. The third part is related to the volume of a cone, but the fourth part has to do with the surface area of a sphere, but we're not going to worry about that. You just need to understand for today that it's 4/3 pi r cubed, and the radius has to be cubed, which is going to give us cubic units. So let's look at the first example of using this new volume of a sphere formula, which is 4/3 pi r cubed. Here's the first example. Find the volume of this sphere, and I have a radius of 4 meters. Well, our volume formula is 4/3 pi r cubed, radius is 4, so I have volume is 4/3 times my 3.14, which we're always going to use for the value for pi, times the 4 meters cubed. So pay attention. Now, I'm writing the radius in parentheses, and I'm putting the cube outside because I have to make sure that I cube the 4 and that I cube the units. If I just put the cube over the meters, it would look like the meters get cubed, but I have to make sure I also cube the 4. So 4 cubed is 4 times 4, which is 16, times another 4 is 64. Meters cubed becomes meters cubed. I have everything the same here. So now what I'm going to do is, which we talked about in the last lesson, I'm just going to move this denominator of 3 down and divide the entire product that we get at the top by the 3. So it's 4 times the 3.14 times the 64 divided by 3. And we're going to use our calculator, and we're going to get volume is 267.9 meters cubed. Remember, round your answers to the nearest tenth, 1 decimal place. So that's the first example of using this 4/3 pi r cubed formula for finding the volume of a sphere. Okay, so what's different is we're now cubing units, and we have to multiply by 4 on the top and divide by 3 on the bottom to incorporate this 4/3 fraction. Your turn. I'm going to give you a problem here. Let's see. I'm going to give you this problem. I want you to find the volume of this sphere, and this one has a radius of 7 yards. So I want you to pause the video, and I want you to answer this problem, and we'll take a look at it. So go ahead and do that now, please. Well, I hope you found the volume of this sphere, and the formula is the same. The radius has changed for this problem. It's now 7 yards. You have to make sure you cube the 7, and you cube the yards. 7 cubed is 7 times 7 is 49, times another 7 is 343. And then the way I wrote this was I put the 4 on the top in the numerator and put the 3 on the bottom as the denominator to divide it all. And hopefully you arrived at this answer, 1,436.0. It's important to show that it's 0.0 because that way you show that you're paying attention to your units, and it's yards cubed. That's the volume for this sphere. All right? Next example. Now for this problem, I don't have the radius. I have the diameter. And again, I did this in different colors to show you that the blue is showing that this has depth, that this is a sphere, not just a circle. If I did just the black, it would look like a circle, but I'm trying to show you that it goes back and extends forward, and we can't really see this dashed line because we'd be looking through the sphere. I need radius, so I'm going to take the diameter of 10, and radius is half of the diameter, so I cut the 10 in half, and I get 5 inches. Now I can plug it in. So it's 4/3 times 3.14 for our pi value, 5 inches cubed. 5 times 5 is 25, times another 5 is 125, and the inches become inches cubed. And I put the 4 on the top, put the 3 on the bottom to divide. So I multiply this out. So that's going to be 4, if I try to do it in my head, which I'm really not going to end up doing completely, but 4 times 125 is 500, times 3.14 divided by 3 is going to give me the volume of this sphere is 523.3. This 3 actually repeats, but I'm rounding to the nearest tenth, so I'm cutting it off, inches cubed. Okay, so if you're given the diameter of a sphere, you need to adjust and find the radius and then plug that in, because our formula is not for diameter, it's radius cubed. Your turn to do the exact same type of problem. I want you to take a look at this. I want you to I want you to pause the video, and you come up with this answer. So, same concept. You have a sphere with a diameter of 18 millimeters, and go ahead and solve that. Pause the camera and let's see what you get. All right, you turned the video back on. I said pause the camera, but I meant pause the video. So you hopefully took your 18 millimeter diameter, divided it by 2, and got a radius of 9 millimeters. Plug that in. 9 squared is 81, times another 9. 81 times 9 is 729. The millimeters become cubed. The 4 goes on the top. The 3 is going to divide. Multiply this all out, and I hope you got 3,052.1 millimeters cubed. One thing I want to point out, now we want the decimal part of our answer to be 1 decimal place, the tenth. That doesn't mean that you're going to cut off your decimal anywhere else in the problem. You're not going to change the pi to 3.1. You're going to use the 3.14. When you multiply this all out, you need to keep the decimal. You do not do the rounding to the last decimal place until the very last step. And once you get your answer and the calculator tells you what the decimal value is, then you round to the nearest tenth. Do not intermediately round to the tenth in the middle of your problem. Otherwise, you won't be accurate. You'll be off by a little bit. So make sure you don't round to the tenth until you're at the very end of your problem. All right, so we found volumes of spheres using the radius. We found volumes of spheres starting with the diameter and calculating the radius. Now we have something new here. This is not a complete sphere. Now, again, I'm trying to represent a three-dimensional object on a two-dimensional flat piece of paper. How much of the sphere do I have here? Well, what I'm trying to show you is this is the top half of the sphere. It's getting cut in half. And if you look at a globe where you've talked about parts of the planet Earth. You looked on a map. What do we call half of a sphere, half of a globe? You probably heard this word before. It's called a hemisphere, which is half of a sphere. Some people even can call it a semi-sphere, but hemisphere is the accepted word for that. That's the definition of what half a sphere is. Now, I need to find the volume, but I'm not finding the volume of a whole sphere. I'm finding the volume of half a sphere. So how much of the volume formula do I need? Well, the volume of this hemisphere is going to be the volume of a sphere as if it was an entire sphere, and then I'm going to multiply it by a half, which is the same thing as dividing by 2. So here's this problem. Let's see. My radius is 8 inches, so I'm ready for that. So I'm going to plug it into the volume equals 4/3 times pi times radius cubed. But then I'm going to multiply by a half, which is going to give me the volume of just half of the sphere. And let's see, when I plug in my 8 inches, I'm going to remember to cube it all. So 8 times 8 is 64, times another 8 is going to give me 512 inches cubed. Now look what I did here. I kept the 4 on the top because the 4 is multiplying. I brought the 3 down to the bottom because it's dividing, just like back when we had the volume of a cone. And then multiplying by a half is the same as dividing by 2. So the 3 and the 2 are going to join in the bottom, and I'm going to end up dividing by 6. So I have my 4, my 3.14 for pi, my 8 inches cubed, which is 512 inches cubed. I multiply that all out. I divide by 3 and divide by 2, or I could just divide by 6 in one shot. And I get the volume of this hemisphere, half of a sphere, is 1,071.8 inches cubed. Okay, so that's the volume of a hemisphere. Now I have a problem for you to do, the exact same concept, and this time the radius is 6 centimeters. So please pause the video. I'm going to leave this up. You can refer to this, and please find the volume of that hemisphere. Do that now. All right, I hope you were able to follow the same sequence, and we're going to use half of the volume of a sphere. So we're going to use 4/3 pi r cubed times a half. Our radius is 6. So when we put our 6 centimeters and we cube it, 6 times 6 is 36, times another 6 is going to be 216, and now the centimeters are cubed. The 4 stays on the top, and I'm going to move the 3 and the 2 down to the bottom. Hopefully you multiplied all this out, and you arrived at the volume of the hemisphere is 452.2 centimeters cubed. So we've tried some different volume of sphere problems. We did some where we actually had the radius. We did some where we had the diameter and you had to convert the diameter to the radius in order to plug it in correctly. We incorporated this 4/3 as the fractional coefficient in the front. And we even did some half spheres, which are hemispheres, by just taking this formula and dividing our final answer by 2 to arrive at the volume of a hemisphere. Now, I have some problems for you to try. They're in PDF format. You can print them out. I would like you to show your written work on the paper, and you can either, I want you to take a picture, and you can either upload the picture of your written work to this Google Classroom page, or you can send me an email. And if you have any questions, please send them along as well. Well, I hope you understood that. So we introduced the concept of finding the volume of a sphere, and we're going to continue on with some higher level problems for this lesson, and I will see you at the next lesson.